The goal on a question such as this is to first get a single logarithm and then apply the definition of logarithms to be able to solve something that looks like something we've seen before. Now we've got both of these in base 5, which is going to allow us to use the product rule for logarithms. We've seen it used in both directions. Before applying that, though, remember that the domain of a logarithmic function is that you have to be putting in positive numbers. So for the first one, we've got that x is going to have to be greater than 0, but also from the second, that x minus 24 will also have to be greater than 0. That second one, if you add 24 to both sides, that's not going to change the direction of the inequality symbol. Now, which one of these leaves out more numbers? What's more restrictive? If you have a number line, 24 is further to the right, and x greater than 0 is going right, x greater than 24 is going to the right. You're going to be leaving off more with that second one. So we're going to go with the second one as telling us what kind of answers we're going to require. Now, using the product rule for logarithms, we can put this left-hand side back together as the product of x times x minus 24 inside a logarithm of base 5. That's going to equal 2. And if we apply the definition of logarithms, the base is 5. The exponent, the answer to the logarithm, that's the exponent, 5 squared, by a process of elimination, that has to equal the arguments of the logarithm, i.e. what was inside. On the left-hand side, I'm going to distribute the x. And on the right-hand side, do the arithmetic. Since we have x to the second power, we're dealing with a quadratic equation. And there are a number of ways that this could be solved. But the quickest is going to be to factor. It's not the case for all quadratic equations, but since that's a 1x squared, I know I'm looking for a pair of numbers with a product of negative 25 and a sum of negative 24. And the two numbers that'll do that I'll put in the parentheses for the x's are negative 25 and positive 1. Set each factor equal to 0. And then you've got two linear equations to solve. Now, if I hadn't talked about this in advance, I wouldn't know that the negative 1 needs to be rejected. I'll show you what happens if we try to plug in each into the calculator and how only the 25 is going to work as a solution. So if I put in 25, I'm going to have to use change of base. Natural log of 25 divided by the natural log of the old base. Of 5 plus, well, 25 minus 24, you could actually put this in the parentheses, but hey, that's going to be 1. And hopefully you already know that the logarithm of 1 in any acceptable base is going to be 0, but log of 1 in base 5, you change a base, type it in this way. Got them added together, what you get? 2. Let's see if I can find where my error is. There we go. Whereas if I try to put in the -1, that's going to be a problem for both of these. But even if you put it into one of them and you're taking the logarithm of a negative number, the calculator is going to balk at us. -1 minus 24 is -25. Got to use the negative sign, not the minus sign. And it's giving us a domain error. So our only solution here is the x equals 25.